All right, everyone. Welcome to our annual coverage of the AWS reInvent conference. I'm here today with Bratin Saha. Bratin is Vice President and General Manager of AI and ML at AWS. Bratin, welcome to the TWiML AI podcast.
Thank you, Sam. Glad to be here. Thanks for having me.
Absolutely. Let's just jump right in. I'd love to have you share a little bit about your role and background with our audience.
So, I'm VP for AI/ML at AWS. That includes a bunch of our AI services, things like personalized forecasting, health AI services, edge ML services like Panorama, and so on. AI DevOps, where we use AI to make it easier to run DevOps or for software development. And then that includes the middle layer of the AWS services, which is SageMaker, which is our flagship machine learning service, as well as the ML frameworks and infrastructure, where we provide both custom hardware, GPUs, as well as machine learning frameworks. And then prior to coming to AWS, I was at NVIDIA, and then prior to that at Intel.
This year, as has been the case in years past, AWS has a lot to announce at reInvent on the AI and ML front. One of the things that I've noticed is that the announcements are catering to two different communities this year. There's a set of announcements focused on making ML and AI more accessible on the AWS platform. There's also a set of announcements that seem to be aimed at more complex use cases, more mature users. And I thought maybe a good place to start our discussion is hearing kind of how you're thinking about the market and where we are and the context in which AWS is releasing these new offerings. I know one of the ways you think about that is in terms of industrialization of machine learning. Share your perspective on that, please.
Thank you, Sam. Yes. So it's indeed true that we have been releasing and we are going to be releasing features in terms of customer personas. One of them, as you suggested, is the machine learning practitioner, and our goal there is to make it easier and easier to build machine learning models and train and deploy machine learning models. And to set some context, this year in 2021 we have customers who many of whom want to deploy 1 million models each, and they want to be able to train models with billions or tens of billions of parameters. Now think of it, if you go back 3 years, let's say when we launched SageMaker, at that point of time the state of the art model used to have like 20 million parameters, and now we are talking of tens of billions of parameters, maybe even more than 100 billion parameters. So that's the scale at which machine learning is growing. And then we have customers who want to do hundreds of billions of predictions per month. And if you look at the data labeling services, we are labeling more than 1 million objects a day. And so what that has meant is that machine learning is no longer really a niche. It is something that today on AWS, more than 100,000 customers are using it, and more machine learning happens on AWS than anywhere else. So we see kind of the need for industrialization potentially ahead of others. And so what we are trying to do in here and what customers want us to do is to make it easy to deploy machine learning at scale and automate it and make it repeatable so that there are no errors in it. So that's the industrialization front, which is how do we make it easier for people to use and deploy machine learning. Then there's the other vector, which you also pointed out, which is that the demand for machine learning practitioners is growing much faster than companies can hire them. There's a survey by a third party that said the demand for machine learning and AI practitioners has been growing by 74% annually for the last 4 years. 2x more than any other emerging job category. And so many of the customers told us that can you make it easier for us to have more employees do machine learning, not just data scientists and ML practitioners, but others as well, like data analysts, like marketing and sales professionals. And these are employees who use the data, who understand the data, who would benefit from these machine learning insights. And so that's the other one where we are going in and saying, how do we fundamentally change the paradigm and make it possible for people who may not be machine learning practitioners, who may not have software coding skills, yet do machine learning? And so that is where we are doing a lot of no code, low code tools. And that is where SageMaker Canvas comes in. And so it's really about two things. One is democratizing access across many more employees through no code, low code machine learning tools. The other is making it easier and easier for machine learning practitioners to build and deploy machine learning at scale, because the amount of deployment going on has really increased a lot by orders of magnitude.
Awesome. Let's maybe jump right into some of the announcements. You mentioned Canvas, and that is a no code environment. Tell us a little bit more about the kind of the design center of Canvas and what you're going for there.
Yeah, and this is a time when we are taking SageMaker to a new audience. Up until now, we were looking more at ML practitioners, ML ops engineers, software developers, and this is going to an audience like analysts and sales and marketing professionals who don't want to necessarily be doing coding, but who still want to be using machine learning. And so Canvas is, we completely redid the UX. We completely redid the UX so that it starts from the use case. You may want to do churn prediction, you may want to do sales forecasting, and so on. So it starts from the use case. You don't have to write a single line of code. You can access data sources, multiple kinds of data sources, on prem or in the cloud. And then Canvas will automatically do the data transformations that you need to get done. It'll automatically build the right model for your use case. It'll help you deploy the model, all of this without writing a single line of code. And then it'll also explain to you why it's making certain predictions. So for example, let's say you want to use it for churn prediction. It'll tell you, here are the reasons why I think this customer may churn. So it's not just giving you insights, it's giving you actionable insights, because it tells you why it's doing something. And all of this, as I emphasize, without writing a single line of code, so that we can make it really accessible. And I'm really excited about how Canvas will make machine learning accessible to a lot more employees. Now, the other innovation that Canvas brings is that it's very easy for an analyst or a user to export all of the work that they have done on Canvas onto SageMaker Studio. And so think of it as, you're building your machine learning models and all that, but you can again have an expert data scientist look at everything that has been created. It's almost like, say, in the software industry, you're writing code, you want someone to code review before you push the code into production. And so that is another of the key innovations we bring in here, is we increase the collaboration between an analyst, user, as well as a data scientist.
I was going to ask about that last point. Traditionally, with no code environments, it's often perceived by technical folks as being a bit of a trap in that um, you can do a lot of configuration and get from say 0 to 1 or 0 to 1/2 even, just clicking around on the screen. But then when you want to get to, the next level, you end up running up against the wall. It sounds like here Canvas is a front end that's building the code artifacts on the back end, and I can take those and extend them and build on them. Is that the case?
It is exact. It's a front end. It's using the same backend that SageMaker uses. It's the same backend that customers are actually using to train models with these billions of parameters or deploy millions of models. And Canvas is going to export the source code for everything it generates. So it's going to give you the source code for the models, for the data preparation routines, and so on. So a data scientist can then use that as a starting point and refine it further.
When you think about Canvas and the process of delivering that as a product, what were some of the key challenges in delivering it?
The important thing that we wanted to keep in mind was, how do you raise the level of abstraction so that it's easy to use while at the same time not raising the level of abstraction so much that you can't do useful stuff with it. And that's often the trap, as you very rightly pointed out, Sam. That's very often the trap that you fall in with these no code low code tools. The second one was, how do you design the UX in a way such that you convey the central concepts, but you don't expect the user to have a deep understanding of machine learning? Like, if you were doing this on SageMaker Studio, you would have a graph and you say, well, this is the AUC, the area under the curve, and so on. Now you can't really use those terms for someone who may not be a deep practitioner of machine learning. Similarly, explainability. You want to be able to explain in a right way that, okay, this was the input, this is the input that's contributing most to the output. So it's really kind of threading the needle so that you have raised the level of abstraction and made it really easy to use, while at the same point you still allow interesting things to be done, and you're explaining all of the concepts in such a way that you're not overwhelming the user with machine learning knowledge.
Hmm. And is there an example of one of those trade-offs that you made in the product and how it played out?
Yeah, so one of the things, for example, is if you think about a normal, as kind of a SageMaker Studio kind of an environment where you have a notebook, and a notebook is an interactive environment for doing machine learning. So you do get an interactivity there, and you know what's going on. In the case of Canvas, we couldn't give that interactive environment like a notebook. It has to be a much higher level. And what that means is that your backend needs to be much more snappy now, because you can't really take a few hours to train your models. You need to be able to give quick feedback. You need to have indicators that says how much of the job has progressed. You need to be able to explain it at a much more intuitive level what your data sets look like, what kind of data permutations you're allowed to do, what kind of filtering you're allowed to do. So we really had to rethink from the perspective of a very different kind of a user.
And I imagine, given the description you just gave, that the target use cases are kind of those core uh, structured data types of use cases, as opposed to computer vision or NLP or things like that.
Yes, it's really more of structured data, tabular data, sales forecasting, churn
Yeah.
prediction, fraud detection, that kind of stuff. Like, things that a data analyst or, sales professional, marketing professional is using all the time. So it's really meant for tabular structured data.
Awesome. Along those lines, targeting this kind of democratization end of the user spectrum, if we can say it thusly, you are also announcing SageMaker Studio Lab. Tell us about that offering.
Yeah, I'm really excited by what SageMaker Studio Lab will enable students and other experimenters who want to quickly get started with machine learning. So, SageMaker Studio Lab offers you SageMaker notebooks. It's integrated with GitHub, so it makes collaboration easy. It's pre-packaged with all the popular machine learning tools, so that a student or an experimenter, or for that matter, any user, can quickly get started. It gives you free compute and it gives you free storage. And more than that, you don't have to do things like shutting down your instance or saving your work, saving your models after your work is done. Studio Lab does it for you. So it's as easy as closing your laptop and then coming back to it and resuming your work again. And it's no setup, no charge. What that means is you don't even need an AWS account to get started. You can just use your email address to log into Studio Lab and get started with it.
That's a change for AWS.
It's a new kind of a product. We think machine learning, our customers tell us that they really want us to make machine learning much more easily accessible. And so we really looked at what are the friction points. And there are a lot more. We believe there'll be a lot more people wanting to do machine learning tomorrow than there is today. And so it's really important for us to help customers leverage machine learning, just as we at Amazon have been doing it for a long time. And so we think it's really important to make it easy for students, experimenters, others, and customers to get started. So it's indeed a pretty groundbreaking, game changing product.
There are other lab offerings out in the market, and they are typically limited by the amount of time you can access them or the type of compute that you can get access to. What are the constraints with Studio Lab?
So we have talked to customers and we have looked at the typical usage scenario, and the kind of limits that we have, we believe are more than sufficient for the typical usage scenarios. So you can use both CPUs and GPUs. And there's a time limit for it, 12 hours at launch. But those should capture the majority of the usage, and you get not just CPUs, but you get GPUs as well. And the other thing that I'll mention is it comes with there is encryption at rest, encryption at transit. So it comes with really good security properties, and that is really hard to build because you're building this thing where you expect a lot of people to use it because of the nature of the product. At the same time, you want to make sure that this is something that maybe a scientist at an enterprise is comfortable using it. And so we had to take a lot of care to kind of marry these two paradigms, in the sense that you just don't want to throw out an AWS product that doesn't have the highest levels of security. And then the other thing that Studio Lab, in my mind, does really well is it's not two different islands. It's not that SageMaker Studio Lab is a separate island and SageMaker Studio is a separate island. And SageMaker Studio is, the enterprise class, the most popular machine learning platform today for enterprises. When you're using Studio Lab, you can actually easily transfer all of your work to Studio. Okay. And so, you can get started, you can do your training with a small data set if you want, do some experiments. And then you say, now let me actually do it on a much larger data set, or let me use a much larger model. You can just export all of your work to Studio and then get all of the features that SageMaker provides. So I think that, that thing of still providing good enterprise class security guarantees, while at the same, so we didn't make it two different islands, while at the same time giving it all of the properties of free compute, free storage, easy to use, easy to get started, no AWS account needed. That needed a lot of innovation by the teams.
Is there a free compute component to Canvas, or can you export from Canvas to Studio Lab to do training?
So we have a free tier in Canvas as well. And we have looked at how customers would want to get used to it and see the power of the tool. So there is a free tier component of Canvas that customers can get started with. We haven't yet had customers really ask for an export from Canvas to Studio Lab. They have asked us for Canvas to Studio, so we are going to be releasing that. But if customers want it, we'll do it.
Maybe one last question on the topic of democratization. Um, yeah, I've been going to reInvent for a long time, and one of the hallmarks of early reInvent was the cost of compute would drop from year to year to year. Do you see the same thing happening on the machine learning side? Obviously there's a relationship between democratization and the cost of accessing services like these.
Indeed, yes. That's a great question. So, um, we are doing a lot of hardware and software optimizations to pull down the cost of compute. At the hardware level, first, if you start with Inferentia provides customers with up to 70% lower cost than previous generation and comparable GPU instances. And then we also launched Trainium in preview, and Trainium is going to provide the best price performance for training machine learning models in the cloud. And then if you look at our for inference, we have a G5 instances, and the G5 instances are also much more powerful than the previous generation G4DN instances. And the same with on the machine learning training side, same with the P4D instances. which are up to 60% lower cost than the previous generation P3, P3DN instances. So there's that aspect of reducing the hardware infrastructure cost by continuously innovating, bringing out new GPUs, bringing out new custom accelerators. Then there is the software optimizations that add on top of it. Okay. And when you think of that, for example, we are releasing serverless inference. And what serverless inference does is it gives you pay per use. So there are many use cases where, say, think of a restaurant recommendation from an online food delivery site, where you have your workload is very intermittent. And so customers don't want their instance to be running all the time at that time. And so today they build complex workflows to shut down their instances. So we are bringing out SageMaker serverless inference that will automatically provision instances for you, scale it up and down based on your traffic, and then shut down the instance. So if there's no traffic, you pay nothing. Then there are these other use cases where customers are going for what I would call, hyper personalization, where they deploy lots of models, maybe up to a million models or more, where they want to be able to really customize it to their end users' needs. And then they say, well, if I'm going to deploy so many models, I don't want to allocate so many instances. And so we have features like multi-model endpoints, which let you host up to a million models in a single instance. And then we do all of the work of caching things in and out. So the combination of both hardware infrastructure optimizations and software optimizations should continue to give customers what they're used to, which is the cost of compute, the cost that they're paying for compute going down just as it has in the past.
Yeah, that's a great segue into digging into some of the more complex use cases that you've referenced, customers with a million models. And I think the first question I have on that is, can are there patterns that you see to the customer journey, relative to, where they start and how they get to having a million models? What does that typically look like, or what are, there's some examples that you can share of the trajectory for customers that make it there?
In typically customers will initially start with um, not very complex use cases, something that has concrete business value, but at the same time isn't kind of at the bleeding edge of the spectrum. And the initial pass is really to get your data in order. So make sure you have enough data, clean data, you have data lake and all that set up. Then pick a significant use case that demonstrates clear business value, yet is not that difficult. And that is where we typically see customers start their proof of concepts. And once they have deployed, a few models, a dozen models, then they just scale it out to, thousands of models, tens of thousands of models, and even more.
Are there inflection points along the way that are kind of markedly different, as you pass them?
I think what happens is as you get beyond a certain point, it's no longer just the machine learning or the model data aspect of it that is important. At that point, your processes and your mechanisms and your automation become equally important. And it's a lot like, say, software. When software, if someone is writing small little pieces of code, it's one thing. But once you get into production massive deployments, you need your CI CD, you need your automation, you need your tools, all of which is needed to make sure that the process of creating, whether it's software, whether it's models, what have you, that the process of it is repeatable, automated, reduces errors. And so what we have seen is, the initial few model deployments, initial few proof of concepts, you can do them in a little bit of an ad hoc manner. And many customers can do it because they want to go fast and they want to be experimenting with it. But Sam, as you pointed out, you get to a point when that is no longer sustainable. And so that is when you really need to look at what are my ML operational practices, or ML ops. What are my ML operational practices? How am I automating the end to end workflow? How am I looking at audit and governance? What is my security posture? All of these come into the picture then. And so at that point, you really have to make sure you put in all of these, and that is what really helps you scale.
You referenced this as industrialization earlier, and just thinking about the list that you just rattled off of concerns, you know, operationalization, ML ops was just one of those things. You think of industrialization as a superset that includes ML ops, or are they more or less synonymous?
So we look at industrialization as a superset of ML ops, and we really look at industrialization as three different vectors. One of them is the infrastructure. And as you mentioned, the cost of the infrastructure, the performance of the infrastructure has to keep getting better. Like if you look at, let's say, the machine learning models, 3 years back when ResNet was the state of the art model, you were looking at about 20 million parameters. Now you're looking at GPT class of models, we're talking about billions of parameters. And so you need your compute infrastructure and the software infrastructure around it to keep getting faster so that you can do these things. So one vector for ML industrialization is performant and cost effective infrastructure. The second aspect of it, which we look at, is tooling. These are tools that are custom built, purpose built for machine learning so that they can reduce the heavy lifting in all of your machine learning tasks. And these are, machine learning development environments like machine learning IDEs, machine learning project management systems, machine learning bias detection tools, and then debuggers and profilers that are customized for debugging and profiling machine learning models. So all of these tools that help it easy, that make it easier for the developer to be more productive and churn out a lot more. And then there's the third aspect of it, which is the automation aspect of it, which is what ML ops is. So we really look at it as infrastructure, which is faster and cheaper, tooling, which is easier, and automation, which is automate and reduce errors and scale it out.
One of the announcements that I wanted to have you share a bit about was, I guess you would say it fits into the first two of those vectors. It's the work that you've been doing around compilation. Can you talk about the SageMaker training compiler?
Yeah, it's one of the first times that really we are, that machine learning practitioners are going to be able to use a machine learning compiler. This comes integrated with the versions of TensorFlow and PyTorch that are available in SageMaker. So, users of these popular packages will be able to use the compiler by default. The compiler, the way this came out is customers told us that these days the data scientists spend a lot of time optimizing models, and there's a lot of craftsmanship involved in optimizing these models, especially when you're looking at recent large natural language processing models with billions of parameters. Optimizing these can take weeks or months of effort. And so we said, okay, how do we reduce this pain point for customers? And we do think that compilation is going to become the standard in how machine learning, especially these large quality models are being run. And so we built this machine learning compiler, and it provides up to a 50% improvement in performance automatically. You don't have to change your workflow because the compilation happens in the background. And it does this by generating more efficient code for GPUs. So it's able to use the GPUs much more efficiently. And we think it is yet another tool that does the things you mentioned, which is, it's a tool that makes it easier for you to optimize models, and at the same time, you ultimately get better performance or lower cost because things just run faster.
And now this isn't AWS's first experiment or first product that's based on compiler. A compiler Neo had a compilation aspect to it based on TVM, open source project. Is this one also based on TVM?
It is. So it shares some lineage from Neo. And as you point out, Neo was meant for compilation on edge devices. So the constraints there were more about how do I reduce the memory consumption, and how do I reduce the footprint so that it can be executed on edge devices. In this case, it's more about, in the cloud, so we don't really have the similar kind of constraints in terms of memory footprint and so on, resource constraints. It does use the similar intermediate form as TWiML, and we have also used XLA for the front end, so that we could compile down from TensorFlow and PyTorch onto the intermediate representation. But there's a lot of heritage that they share.
Got it. And in terms of and the focus for this is specifically training as opposed to inference.
Right. It's really training, and I think customers will really get benefit when they use these large models, like these recent large natural language processing models, because especially when if you're training something for many hours, that is when getting a 50% boost helps. So if you're doing, let's say, smaller models, XGBoost, or these regressions and so on, which these days can run in minutes in powerful machines, their customers won't see a lot of benefit. So it's really intended for these large models, which are becoming very popular with customers these days.
And how much are you seeing folks training these large models from scratch relative to kind of transfer learning, fine tuning, and using a pre-trained model?
We are, so in let's say the GPT-2 kind of a GPT slash star kind of models, or whether it's Robota or GPT star. In these large models, we do see customers training them from scratch. And we have seen customers who take these models and training them on different corpus of text, for example. Someone wanting to train it on a corpus of financial text, someone wanting to train it on a corpus of other different kinds of text. So we do see that happen. I mean, transfer learning is also there. We have also seen some customers start with a pre-trained model and then do transfer learning. But many of our large customers, many of the startups are actually taking these large models and training them on different bodies of text to be able to create much more customized offerings.
Got it. You already mentioned the serverless inference announcement and the new offering there. Um, can you talk a little bit about the relationship between the SageMaker serverless inference and Lambda? To some degree, folks have been able to do inference via AWS's existing serverless tooling like Lambda, uh, although with various limitations associated with that environment. Can you talk about how these fit together and what's new with the serverless inference approach?
So this is a fully managed offering. So you don't have to do any of that management. The second is, this also gives you a lot of the machine learning capabilities and tooling that you would expect. So let's say things like, this will give you things like model monitoring. And we are also working on making it easier for customers to bring models in their own container formats, so that it's easier to use. So it's really a combination of a fully managed offering, giving you the machine learning capabilities that we think are really important when you're thinking of production deployments. And then the third aspect is giving a lot more flexibility, and we are going to bring that up over the next year, giving a lot more flexibility in how you create your containers that you can use to deploy on the serverless end.
And so the what does the developer experience look like with serverless inference? So there it sounds like they're providing a model artifact in some format and potentially as a container.
Yes. Actually, along those lines, before I get to that one, we are also releasing another feature that we call SageMaker Inference Recommender. So think of it today as, if you have to do model deployment, then first, and I'll get to your question around what it works like, the serverless inference. So today, what an engineer has to do is they have to figure out what is the right choice for me. If I'm doing online inference, there are more than 70 instances that you have to choose from, or you do serverless inference. And then once you have chosen it, you need to configure it. Then once you have configured it, you will need to run load tests on it so that you know that it will be able to withstand the traffic. And then once you have done that, you may have to optimize the model for the instance. So what SageMaker Inference Recommender does is you give it the model and you give it, your use case requirements. It will automatically recommend the right instance for you. That's going to give you the optimal price and performance. So as a first step, you can actually come to the Inference Recommender and have it figure out which one to use. Now, if serverless is the right option for you, then you do it as you mentioned, which is, you basically give it the model artifacts. SageMaker is going to provision an instance for you based on the needs of your model, and then it's going to scale it up elastically up and down based on the traffic. It'll shut it down if there's no traffic. It'll bring it back up whenever it sees traffic, and you're only paying per use. So if there's no traffic, means no charge.
Got it. So going back to Inference Recommender, can you talk through how that's working? Is it profiling a live instance of your model and trying to understand its resource requirements, or is there some other?
So when you give it your model, it will run a benchmark on different instances, and then it'll find out which one of those instances provides you the best performance or the lowest cost, and then it'll give you a recommendation that says, this particular instance, maybe Inferentia for example, is giving you the best performance or the lowest cost, and then you can go and choose it. So it basically runs a number of tests, and it also allows you, the user, to then use it to do load testing on a variety of other instances as well. So at the back end, there is a framework that is doing, think of it as a bunch of performance measurements and cost measurements related on the set of instances, and then lets you make the choice.
Mhm. And I'm imagining that in a serverless environment, that same kind of benchmarking that you're allowing customers to do with Inference Recommender to get kind of the either lowest cost or best price performance instances, AWS might want to do that to manage its own costs. Like, is this an example of exposing functionality that existed kind of within the cloud, or is it its own thing?
In some ways, it's in response to what customers told us were some of the pain points in model deployment, because customers said today we have to do this work ourselves and we have to build an infrastructure to do it for us. In our case, it's a little hard in general to do it, because customers own their own models and data and all that. We have no knowledge of it, so it's hard for us to look at that. So this is a feature where customers are coming in and providing their inference containers, and then we can go and make these changes. But it's a little hard to do it in general when we don't really have any visibility into their models and data and so on.
So much so far, but there's at least one more, SageMaker Ground Truth Plus. So Ground Truth has been around for a few years now. This is essentially kind of a higher level of abstraction on top of Mechanical Turk for data labeling. Ground Truth Plus is a better version.
Ground root plus gives you more. Yes, so yeah, I guess we could have, it's a plus plus. So what happens today is, as the need for data labeling has gone up, and we have customers doing terabytes and petabytes of data, as the need for data labeling has gone up, many customers have teams of, say, data operations managers, program managers, who are responsible for producing high quality labeled data. Now, today, when you're using ground truth, or even in general, these customer teams have to set up the labeling workforce. And then they have to validate the output of the labeled data. Then they have to manage some of these workforces. And that can be daunting for some of these uh, teams. And so, what Ground Truth Plus does is it gives you a fully turnkey operation. So, you as the customer, you give a Ground Truth Plus the data, and then Ground Truth Plus does all the rest. It looks at your instructions. So let's say you want your data to be labeled by people who are experts in video labeling. Ground Truth Plus will select labelers who are good at video labeling. It will then do the validation of the label data. It will do the management of the labeling workforce. And then not just that, Ground Truth Plus embeds machine learning into the data labeling process. So we are using machine learning to do data labeling for machine learning. And what it does is it uses machine learning models to automate the labeled output. It also uses machine learning models sometimes to pre-label the data. And what this means is human labelers no longer have to label it, they just have to verify that the labels were done correctly. And that makes the labeling process much more efficient, reducing costs by up to 40%. And so, what we are doing in here is basically removing the entire friction from the data labeling process, because you just give us the raw data and we hand you back the finished labeled data.
Awesome. Awesome. Well, as is always the case at reInvent, there is a lot to review and absorb and kind of wrap one's brain around. For you, Bratin, what are you most excited about among all of these new offerings?
I think Studio Lab is going to be really impactful in making machine learning accessible to a lot more students, experimenters, someone who wants to quickly get something done. I think Canvas will be a game changer in making machine learning accessible to a lot more people. And so, going back to the initial thing that you said, that this is along the democratization, make machine learning accessible to more people, that vector. I think on the make machine learning easier for machine learning developers, I'm excited by what the model compiler will do, because I think over time we are going to expand the amount of usage. So those are really important. Ground Truth Plus also makes it much easier to do data labeling, and data is the fuel for all of the machine learning. And we keep innovating on performance and cost. So I think those are the things that I think customers will find really helpful.
I think you just said everything's your favorite.
Well, it's hard to pick between so many things, but I think if I had to pick the top three, I would pick Studio Lab and Canvas. And then on the technology side, I think the model compiler, because I think those are
Yeah.
really going to push the frontier in new ways.
Awesome. Awesome. Well, Bratin, thanks so much for getting us all caught up on AWS's announcements.
Thank you, Sam. It was really nice talking to you.